So we are still in the short run. Last time we started already talking about a little bit the short run, that in the short run the economy might be running below potential, that we have unemployment, or that the economy is doing really, really well and unemployment is unnaturally low. So we're continuing in that line of thinking, and today I want to show you the IS curve and even a little bit more detail. We want to learn about the multiplier effect and the IS curve. So just that you see where we're going with this, we're basically starting with aggregate demand, something that we've learned in week 1, I think, already. Don't worry, I'll repeat a little bit. But we make that a little bit more complicated. We make aggregate demand a function of income itself. And that will result in the multiplier effect. And we immediately include a second change as well. We say real investments, so how much companies are buying trucks, new machinery, new businesses, is going to be a function of the real interest rate R. And that's going to result in the so-called IS curve. So that will keep us busy for roughly an hour, I think. Let's see how we're going. So a new diagram. I don't think we had this diagram ever beforehand. In this diagram, we've got here actual GDP. And up here, we've got aggregate demand. And you might recall that aggregate demand is nothing else than consumption plus investment plus government expenditure plus exports minus imports. I can't believe I put an arrow straight on the first slide. Sorry for that one. So this must be a minus here. That will be wrong on all slides now. Net exports here should have been minus imports. Good. Now, why is this one here so complicated? As I said beforehand, we are including now the fact that aggregate demand, especially consumption, is going to be a function of actual GDP now. So this one is bold. Might be worth highlighting on your slides. And investment is going to be a function of the real interest rate. Now let me talk about some of the other stuff too. What does this one here mean? A, C, Y, T. So you notice there are heads over this one. That just means we take them as exogenous for the time being. So we don't need to worry about them. That basically says that as a function of how GDP usually should be, for example, we are in a rich country, so we have fairly high GDP. People are always consuming some, even if income is low, even if growth in Australia is not much. Right now, if growth is slowing down, people are still consuming a certain amount. And we just take this as given. That's the reason why they're heads over this one. So you can imagine this one as a certain minimum normal consumption. Maybe minimum consumption is better than normal consumption. But here's the second part, and that says, well, if the economy is doing exceptionally well, so if GDP is higher than potential GDP, so if the economy is booming, then the bracket becomes positive, then people consume more than usual. So X is saying how much of that additional income, basically, people are consuming. Let's say, for example, you usually make $60,000 a year, and now in 1 year, you get a $6,000 bonus. So the $6,000 bonus would be your brackets here. You would be $6,000 higher in income than you usually are. And X is basically telling us a fraction of these $6,000 that you are spending. Because remember, we're talking about consumption here. So if you're a big spender, your X would be 1. That means any income that you get above your normal income, you immediately go shopping, big time. And if you're more thrifty, and maybe make it 50-50, then your X would be 0.5. So you get $6,000 more income, but your consumption is only increasing by 0.5 times 6,000 is $3,000 would be your increase in aggregate demand. Everybody on board? So the basic idea, even though it looks complicated, the basic idea is just that we have in here now consumption as a function of extra income or income changes. Income that is either above the potential or the other way around, below 2. So for example, if you had a bad year, you might not get any bonuses. In fact, you might have had unpaid sick leave for a while. So you get in this year $6,000 less than usual. And you have 0.5. That means your consumption is cut only by 3,000, even though the income dropped by 6,000. If your X would be 1, you would cut 1 for 1. Income cut equals consumption cut. For the time being, let's forget about the other stuff because I'll explain that in more detail later. I just want you to focus on this bit here. That is important. So now we can plot that too as a graph. So you can imagine everything else is fixed. So we basically have aggregate demand as a function of x bar, so something constant, plus x bar times the difference here. And you can see hopefully the bigger yt, so the more we go to the right, the bigger consumption and hence the larger aggregate demand. So we've got a straight line that is upward sloping. And just to see that everybody is on board, what is the slope of this line? Where can we see the slope of this line? In this big equation. I can see the class is split. Some people that are good at algebra are smiling and I think that's too easy, while other people have a big question mark on their face. Right? That's the reason why I try. Yep. Yes, it's x bar, right? So if you take the derivative, how does aggregate demand change? Derive aggregate demand after what's written down here because we're after the slope, after yt, well, after yt. Everything else is constant, so everything flies out, and it's just x bar times yt. After yt is x bar. You're left over. Yep, I'll come up there later. Good. So the bigger x bar, the steeper the thing, the smaller x bar, the shallower the black line. What else is important for me on this slide here? Basically, we take everything as given except for aggregate demand and actual GDP. So we've got two variables. Everything else we just can imagine is a fixed number, and we don't need to worry about it for the time being. So for example, x bar might be 0.5. This one might be 50 billion or whatever. This one might be a little bit less, or more actually. Let's make that 100 billion. And so on. Just imagine these are all fixed numbers. So we just worried about aggregate demand and y. So we've got two variables, and we also have two equations. This is one equation here, aggregate demand as a function of yt, and we've got a second equation here. Aggregate demand must also equal in equilibrium everything that we are producing, GDP. Remember we had that in week 1 or 2, that some people's expenditures are automatically other people's income. So if somebody is consuming and spending on consumption, it's automatically other people's income that sell you the consumption good. Or even better, if you think in total real terms, everything that we are consuming, investing, what the government eats, what we're exporting, minus what we're importing, we must have produced. Gross domestic product, right? And everything that we have produced must be used somehow. So that's an equal sign here, and in the graph, equal sign just means a 45-degree line, right? 1 for 1. So we have two variables, two equations that can be solved. In the graph, the solution is simply where they're crossing. Right? That's our equilibrium, as always in economics. Now we do the math solution a little bit later. For now, I want you to focus on the basics. So let's say we change one of those variables. For example, we say we have a new government budget, and the government is saying there will be plenty of new freeways for Queensland, Victoria. The government is going big time spending. So government expenditure goes up. Government expenditure for us here is G. It's part of aggregate demand. So if we crank up G, clearly aggregate demand is going to increase. In the graph here, we are pushing the aggregate demand curve up. So far, so good. Right? Everybody on board? So basically here, the arrow up is government expenditure up. And that is causing the whole aggregate demand curve to simply shift upwards. We didn't change x, we didn't change the slope. So the economy jumps up there, but then we're not finished, right? Because we know aggregate demand must also equal GDP. Why? Or the other way around, GDP must equal aggregate demand. So if aggregate demand goes up, GDP must go up too, and we can see that here. If you have this much of aggregate demand, well, the according GDP is here. So GDP will increase, and that makes sense, right? If the government is spending more, you would think the economic activity is increasing and the economy is growing. But we are not finished yet, because once we are here, GDP has increased, the income has increased. You can just imagine the income of all the people that build streets, people that build the bridges, anybody that the government is paying now, and where the pay increase for these people, their income is going up. And if their income is going up, their consumption is going up too. Right? So you can imagine there's a street building company, they were going so-so beforehand, and now they get a huge government contract to build a new freeway, big spending. Right? They immediately go out, buy new stuff, employ more people, these people can consume more. You can imagine that's quite good for the people and the economy in that moment. So consumption is going up, but when consumption is going up, aggregate demand is going up even further than beforehand, and that's that second red arrow here. So there are so-called secondary effects, like this one. And you can see here, so that's that one, aggregate demand goes up, GDP went up, then we're here, but we're still not in equilibrium, because once GDP was going up, consumption is going up. You can see it here, GDP up, consumption up, hence aggregate demand goes up even more. So we're going up here. Note though that I didn't shift the aggregate demand curve for that one. That's actually a good learning exercise. How come that I didn't shift it? I said here aggregate demand goes up, and I'm going from black line to red line. Here aggregate demand goes up too, but I didn't shift it. I just went from this point over to here. Anybody has an idea? It's something that I've got on later slides, but I just realized now I can teach it here too. So in macroeconomics, I think in micro you had that too, we have to sometimes distinguish between running a longer curve and shifting curves. And especially in this class, it's going to be very important not to mix these two up. And there's a very easy rule of thumb. Was that, yeah?
Because aggregate demand increased because of the X variables, like the income,
Yes, you meant exactly the right thing, but it's not the X variable, but the variable here is called? Income, yes, and the letter for income in our class is? Y. Yes, I know what you meant, right? So usually this one is the x-axis, and you're right. If you change one of these, then we are running along the curve. If we change something outside of the diagram, for example, G is not anywhere in the diagram, then we're either shifting curves or nothing is happening at all. We will use that several times in class today. I will focus on that one later. But that's the reason why, right? So initially, we changed G, and G is not written on the axis, but G was important. It was here in the equation, and hence it's a shift. The second time, we changed Y, and Y is written on the axis. And then aggregate demand is also increasing, but aggregate demand is not increasing due to a shift, but running along. That's the whole point of this equation here. If Y goes up, aggregate demand goes up, but it's running along, not shifting. If you don't have it down 100% yet, I will repeat that several times during class today. Good, so we are not in equilibrium yet, because here this is aggregate demand. Again, aggregate demand should equal GDP. So we go over here. GDP increases even further. Once GDP is increasing further, again here the income is even higher now, because let's say the street building company employed people, the people consume, so now the bakery close to that company is having more business now, so they get higher income, and all the bakery people buy more presents for their kids now too. So their consumption is going up too. So that's represented by going further to the right. And then the people that sell the presents also get more income, and again they go spending more, because their income goes up, consumption up, and so on, so on, so on. So it's getting smaller and smaller and smaller until we get to this point here. Right? So the point of that whole thing is, you can see it in the graph already. So GDP increased by more or less than the initial government expenditure. If you just look at the line. So this is the 45-degree line. If GDP is, let's say, going up by 50, the blue arrow would be how big? 45 degrees? 52, right? So, and we are further than the blue arrow here. So clearly GDP is increasing by more than the initial government expenditure. So the initial impact is multiplied. You can see where we're going with this. That's the so-called multiplier. Everybody on board with the graphic idea? Good, then I move on. So what was the main kicker here? This is just the consumption part, zoomed out, that you can see it a little bit clearer. We talked about this one. This is autonomous stuff. We don't care about that one. But here's the kicker. Because consumption is a function of income. That is what's causing the multiplier. So income up, consumption up, aggregate demand up, income for other people up, other people's consumption up, and so on, so on, so on, so on. Continues. Right? And how strong that impact is depends on X, how much of that additional income people are spending. That's the reason why we also call it marginal propensity to consume. I think our new book doesn't say so, but in all the other books they call it marginal propensity to consume. So how much on the margin we consume of that additional income. The bigger that is, the more people spend, and the bigger that whole multiplier process works. Good. Let's see if you can handle this one. So try to draw an aggregate demand curve now for the case that x dash equals 0. And then afterwards, so just drawing a line that fits together with this description here. And then afterwards, imagine that China is not interested in Australian coal anymore. So Australia is not exporting that much anymore. So there's a shock to the system where exports are taking a massive dive. And by the way, again, here's a typo. This must be a minus. Good. And then once you've drawn that down, 1 and 2, you can scratch your head what happened to the multiplier. And I go around, see how you're going. Good. So that was pretty clear cut for everybody here, it seems. So it would be just because x dash was the slope here. So basically you can imagine if that is 0, the whole impact of y just falls away and the whole thing here becomes a constant, which means a straight line. And then if exports are decreasing, the straight line is dropping down. And we are basically having not a multiplier at all. So the drop here, because we are at the 45-degree line, is exactly equal to the drop in GDP. So there is no additional impact. Or you can imagine it like this. The export company here is having less income, but because x0, the income change doesn't affect their consumption choice. So they consume just as before, and so it doesn't affect anybody else in the economy. There's no multiplication of what's happening there. Good. There was a question up there that helped me a little bit to clarify things too here, maybe here a little bit again. So because the student asked their question, it became clearer to myself too, how we can say this one. So if the economy is running at its potential, so if everything is normal, the brackets become 0. And that would imply that this thing, AC times YT potential, is simply our normal consumption. So you can imagine this one is normal consumption, and this is deviation from normal consumption because the economy is either booming or in recession. That's maybe a good way to think about this. And this is just shorthand. This one just says consumption is a function of Y, GDP, and it's a function in the sense that it's positive. So if Y increases, consumption increases. If Y decreases, consumption decreases. If you see minus sign up here, it just means that they are oppositely related. It's just shorthand. If I'm too lazy to write down the whole equation, I might just write down this one. Or same for you for the exam. If you don't need whole equations, you can just use shorthand like this to help yourself. Good. So that was pretty straightforward. Now solving for Y, I saw one student did it already on the side. Let's see what we've got here. So we've got aggregate demand is the same equation as before. And again, here must be minus. Maybe we fix these up one first. Minus, minus, minus. So I did paste and copy everywhere. That's the reason why the arrow is going all the way through. 1 + 1 = 2. And we want to solve for YT. We want to have GDP on one side. So we've got equation number 1 is aggregate demand equals this whole shebang. And we had equation number 2, which said GDP should also equal aggregate demand. So we can say here, GDP equals the whole shebang plus X times GDP. So we just bring X times GDP over to the other side. So then we have this one here, Y minus X times Y. Then I have X bar times GDP potential with a minus sign. Dang it. Gosh, I really wasn't 100% concentrated when I did this, was I? So there must be a minus sign here too. Next time I do it on paper. And I don't do less errors, I think. So you can see this one here, right? X bar times minus Y T bar is becoming minus X bar in the brackets. Unbelievable. So this one must be a minus sign too. Good, what else do we have? We can bracket out YT here, so then we have Y times in brackets 1 minus X. And I immediately divide it over to the other side. So it's here, 1 minus X under here. And then we have all our GDP, all our Y's on one side. There's no Y's here anymore, apart from the bar ones. But remember, these are exogenous. They're just given numbers. They don't change within our model for the time being. Remember, this one must be minus. And this is our multiplier. That's the kicker here for us. So what else do we have? That's the basic thing that I want to get out of this one here. So we just have all kinds of constants times this so-called multiplier here. And with that one, we can start playing around already. A little bit of discussion. So the multiplier itself. We just got that one out of simple math, so we didn't use too much economics. I gave you a story that people spend and respend their money and blah, 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 but to be honest, it's a little bit of a fairy tale. We don't know exactly how much they're spending. We don't know exactly how everything works. We just know if we assume the economy looks as simple as this, we can just reshuffle things, and then we get that multiplier happening here. And that is highly contentious. So what do people think about this one? Number one, people prefer smooth consumption. So basically, you can imagine if in 1 month you get a lot of income and the next month you get hardly any income, that doesn't mean that in 1 month you go partying and spending big time all the time, and next month you're just living on canned food, right? So you usually save a little bit, and if you have a tough time in your life where your income is even insufficient to finance your normal consumption, then you might borrow something from friends or parents in between to smooth out your consumption a little bit, right? And then if times are going well, you repay your debt or you put some stuff aside, saving for bad times. So people try to smooth their consumption, and that implies that the GDP changes, the income changes, don't affect your consumption one for one. That is still covered a little bit by the X, right? So if the X is smaller than 1, yes, if X is smaller than 1, it already implies that you're saving some of your extra income, and also implies that if your income is cut, your consumption cut is not one for one as big. But then there's some other more advanced ideas, so I'm just touching them very loosely here because I know you have that in year 3, I think, or year 2. So one is that lifetime income. So people think about their consumption, they take their total lifetime income into consideration. Now that might sound a little bit ridiculous if you think about, if you're drinking beer now, that you're thinking how much income will I have in 15 years in order to decide if I have a beer or not, right? But think of, for example, of your standard of living when you decide to buy a car or to buy a house. You don't look at your income for 1 year, 2 years, 3 years. If you make a decision what kind of house you're buying, you're basically thinking already about your income for the next 30 years. And the house is kind of consumption too, right? It's consumption of living space. So people do take long-term income into account. And if they have a hard patch in between for a few months, they don't immediately sell their house, sell their car, and say, oh my God, now I have to live only on canned food, right? People do anticipate what will happen in the future. And that means temporary GDP changes might hardly affect the consumption. That would say that the X, in our case, would be very, very small, closer to 0 potentially. Then there's something else coming to it too, and I have to be careful how much I'm saying because we have Ricardian equivalence in week 12. But I might want to give you the basic flavor of it now already. Let's say the government says we want people to consume more. We massively cut your taxes. In fact, this year you don't have to pay any tax. We finance everything via debt finance, and we simply increase the tax then in the future. How much impact does that have on your consumption? So you get much higher income now because you don't pay any taxes, but because the government is using debt finance, you know in the future your tax will go up a lot. And because you don't want to suffer that much in the future, what might you do with your additional income right now? Save it, right? And the Ricardian equivalence says, well, if you do the math cleanly, and if people can anticipate 100% what will happen, in fact, they save 100%. So in that moment, the government, the finance of the government would have no impact on your consumption decision at all. And then we get Ricardian equivalence. Again, the multiplier would be much, much smaller thereby. So the multiplier all up is highly contested. You see economists that believe basically it's 1 or smaller than 1. It's something called crowding out that we learn in future classes. And then there are economists that say, no, the multiplier is fairly high. And you might remember the reading that we had for today. I think there they estimated the IMF initially said, well, the multiplier is not that big because the IMF is fairly conservative too. But it turned out it was actually 1.5, I think they calculated, right? So it was bigger than they anticipated. And I think as a rule of thumb, at different times in the economy, the multiplier might be smaller or bigger. So when the economy is really in the dumps, so if you're in a deep recession, things are going really, really well, we can say that the multiplier is most likely larger, so you have a larger impact by government expenditure. Because people simply don't have enough to save anyway, so any kind of additional income that you give them, they're happy that they can still afford to consume. While if the economy is running at full potential already, then the multiplier might be smaller. I've got that already, so we had that one. Yeah, it's basically what you had in your readings, right? So the reading related 1-for-1 to exactly what we just did in the graph and in the math, the multiplier. Good. Beforehand we did it with x equals 0. Now we do it with x 0.5. So that means 50% of your additional income you're spending, 50% you're putting aside, doing the same game. But now I want a little bit more from you. I want to get an exact number. So you can draw first the aggregate demand in here. Then let exports drop. Draw second aggregate demand line. And then use this thing here to calculate by how much GDP will change. And I give you a little bit of a hint because people that are good with math will see it immediately. People that are maybe a little bit forgotten about the math might be a bit harder, right? So if you can forget about most of the other variables, what you're focusing on is export is dropping. So basically we're just looking at the change. This one is dropping by 50 million. How much is this going to drop if you write 0.5 here? All the other numbers are unimportant. Okay, off you go. I'll go around a little bit again. So we're going well. Let me see if I can draw it in here. No, that's not what I wanted. So we get an aggregate demand line, and the slope of that aggregate demand line is simply 0.5. Now we are dropping it by 50 million. So export is dropping by 50 million, hence aggregate demand is dropping by 50 million. Old equilibrium, and now the multiplier kicks in, so we go from here to there, to there, to there, to there, to there, and so on, right? So in the graph, of course, we can't see exactly what the number is, but we can use the equation here. So if we know if this one is changing by 50 million and there's no other change, we multiply this change minus 50 times 1 over 1 minus 0.5, which is simply 2. So 2 times 50 means GDP is going down by 100 million. Done. Everybody on board? So I looked around, it looked pretty straightforward to most people, I think. If not, these things says here, important, right? So I want you to be able to do these. Good.